All right, today we are on the third section of chapter 2. We are going to be working on, of course, still finding zeros of polynomial functions. We've already have been working on that a little bit, but the difference is every problem we've given you so far has been nice and factorable and super easy. Well, of course, that's not always the case. So we're going to look at some other skills that are going to help us coming up here to find the zeros. Now, today we're going to do some long division of polynomials. So I thought maybe we should just go old school and start with some 6th grade math. So first question, ask yourself 43 goes into 87 how many times? That would be 2. 2 times 43, 86. Keyword, key step, we're going to subtract those. So 87 minus 86, of course, is 1. We're going to bring down our next number. Now, 43 does not go into 19, so we're going to put a 0 up here. I'm not going to write 0 times 43, 0 and all of that. We can just bring down our next number. So 43 goes into 192 4 times. 4 times 43 is 172. Then I'm going to subtract that, remainder 20. Now we're big kids now, we're not going to put our 20, okay? We're going to put our answer 204 and our remainder over the divisor, which is how we are going to write it today when we do polynomials. Key is anything that we put on top, the 2, the 0, the 4, you multiply by your divisor, 43, and then we subtract those lines. We're going to use the same steps today, but with polynomials. Now, algebra 1, fraction bar still means division. We are dividing 5x squared y cubed by 5xy and 10xy by 5xy. So I'm going to do the first one, 15 over 5, of course, 3, x squared over x, y squared over y. And 10xy divided by 5xy, 2. Not like terms, can't combine them, etc. So just a quick little review of some easy division. So we're going to take a look at 2 different types of division. Long division, synthetic division. Everybody always loves synthetic, but you can only use it on a certain type of problems. And I'm going to talk about the remainder and factor theorems. So here we go, long division. So I'm going to put my divisor out here in front. Now let's make sure our terms in the dividend are in standard form, highest exponent to the lowest. If I was missing a term, I would either put a 0 in for it or leave a space. I would account for that. But nice, we've got everything. I'm ready to put my first term on the top, so I'm going to ask myself x times what is 5x squared? A 5 and an x. Anything you put on top, you have to multiply through the entire divisor. So 5x times x, there's my 5x squared I was looking for. 5x times negative 4. Now, just like on that warm-up problem, we subtract these. I subtract both of them. So it's going to make this a minus and the 20x a plus. So the 5x squareds are gone. I'm not going to write anything. Negative 17x plus 23. And I'm going to bring down the next term. All right, I'm ready for my next term to put on top. So I'm going to ask myself what times x is 3x? 3. So again, anything on top, we multiply through the entire divisor. 3 times x. 3 times negative 4. Again, I'm going to subtract this entire row, so minus and a plus. So we end up with a remainder, of course, of 0. So I'm just going to write off to the side. You could just circle it at the top. My perfect final answer, nice and pretty, 5x plus 3. Got it. Nice, easy, nothing stressful there. Okay, next up, divisor. I'm going to put that out here in front, 2x squared plus 1. Dividend, again, make sure that you have all the terms in the correct order. If I was missing a term, I would put a 0 or at least leave a space so it doesn't mess up your like terms staying in line. All right, I'm ready for the first term. So 2x squared times what is 6x cubed? Well, 2 times 3 is 6, and we need another x. So 3x squared times 2x squared. Careful here, 3x times 1 is 3x, so I'm going to line it up with its like term. I'm going to subtract everything. Now, we don't have an x squared term, so our 10x squared is going to fall through. 1x minus 3x. And we can also bring down our 8. We are ready for our next term on top. So I'm going to ask myself, what times 2x squared gives me 10x squared? 5. Through the entire divisor, 5 times 2x squared. Got it. Now, be careful here. 5 times 1, of course, 5. I'm going to put it under the 8 to keep the like terms together, and I'm going to subtract everything. Now, we don't have an x term, so my negative 2x is going to just fall through, and 8 minus 5, 3. Now, I can't divide any further because I can't figure out what times 2x squared will go down to just a 2x. So negative 2x plus 3 is my remainder. So final answer, I'm going to write it nice and pretty. We got 3x plus 5. Now, we're big kids. We're not putting r, okay? We're going to add on our remainder, our negative 2x plus 3 over our divisor. We are adding on that fraction of an answer. Okay, moving on. One more. Again, nice. Make sure we have all the terms, etc. X cubed minus 1, my divisor. Now x to the 5th to 7, we are missing a lot of terms. I can't say I want to put in 0x to the 4th, 0x cubed, 0x squared, 0. I'm just going to leave a space here, a big space, just in case I end up with an x 4th, x squared, something like that, so I can keep my like terms in line. Okay, first term on top, what times x cubed is x to the 5th? We need 2 x's. So x squared times that, got it. X squared times negative 1, negative x squared. We're going to subtract these, so that's going to go minus, plus. So my x squared, of course, is falling down, and I'm going to bring down the 7. Guess what? We're done. Because I can't multiply x cubed by anything to reduce it down to an x squared exponent. So I'm going to write my answer nice and pretty over here. We are going to add on our remainder, that fraction of an answer, over the divisor. Now, long division you can use on any type of polynomials. You can divide by anything using long division. Doesn't matter what I give you. Synthetic division, of course, everybody's favorite. It is simply a shortcut of long division, so it only works on specific problems. Your divisor has to be a binomial, 2 terms, and your highest exponent on it has to be a 1, so x plus 3. Here our divisor, x plus 2, x minus 6. So I can do synthetic. I could have on these long divisions, I could have used synthetic on A, x minus 4, but it says long division. There is no way, if I had a choice, that I could do synthetic on this guy because our divisor has an x squared in it. Same thing on C, our divisor is x cubed. There's no way I could have done synthetic even if I had a choice. Okay, synthetic division is, like I said, a little shortcut of long division. So my divisor, x plus 3 equals 0. So we're going to find the 0 of this. So if I set that equal to 0, we end up with negative 3. So negative 3 goes in our little divisor box. I'm going to line up the coefficients, the numbers, on the dividend. Highest to lowest. If we're missing any terms, we are going to put a 0 remainder. But we got them all. Okay, I'm going to leave a row, so leave a line to write. And our first term always just drops through. Anything below the line that I just drew, we multiply by your divisor. So I'm going to do negative 3 times 5, negative 15. That goes in my next open space. And we add these 2 rows together. So 18 plus negative 15, 3. Anything below the line, you multiply by the divisor. 3 times negative 3. I'm going to add those together. Below the line, negative 2 times negative 3, 6. Add them up. Now, of course, my answer just is not those numbers. We have to put it back in a polynomial style. Your last number is always the remainder. Just a little FYI. And I'm going to start with the 5. We are always down 1 in exponent on the dividend. So my dividend highest exponent was x cubed. So this is 5x squared plus 3x minus 2. And of course, if I did actually have a remainder, I would put that back in a fraction style over the divisor, which we will see in some upcoming problems. So here we go, let's practice again. So first things first, I'm going to set my divisor to 0, find the 0. You can do that, of course, all mentally in your head. Now, on your dividend, be careful here. The terms are not in the correct order. My highest term, of course, is the x cubed. 8x squared should be next, then the negative 9x, then the negative 18. First term drops through. Negative 2 times 4, we're going to multiply 4 times our divisor. Negative 2 times 4, negative 8. We remember, add these together. 0. Negative 2 times 0. Add negative 9 and 0. Negative 2 times negative 9, add. And of course, the last number, don't forget, it's the remainder. I can write my final answer. 4, of course, we're going to be down an exponent from the degree of our dividend, so x squared. I'm not going to write anything for 0x minus 9. So again, I can't stress the importance of making sure the terms are in the correct order. And if you are missing a term, we're going to put 0 to hold the place. All right, let's get our divisor here set to 0. Obviously, you can do that in your head. Our divisor is going to be 6. Now, we are missing some terms here. We go from 10x to the 4th, negative 50x cubed. There's no x squared. There's no x term, negative 800. We do have to put the zeros in, so we keep our like terms together here. Okay, first term, of course, always just drops through. We're going to multiply by our divisor, 6 times 10. Of course, we're going to add these together. 10. 6 times 10 again. Add 0 and 60. 6 times 60, 360. You might need a calculator for this. 6 times 360 is 2160. And then I added negative 821.60. So this time we do have a remainder. Now, big kids, we're going to write that, of course, in fraction form. So final answer, I'm going to start with the front 10 here. We are down 1 in power from the dividend, so that's 10x cubed, 10x squared, 60x. And then our constant term, just the number, 360. And then just like before in the long division, I'm going to put my remainder over our divisor. Our original divisor is x minus 6. So if you're quick at multiplying and adding, these go by very fast. Now again, we're going to use these skills to help us find zeros on polynomial functions that don't factor. That is what we are working our way up to. We're just getting the skills under control today. Okay, remainder theorem. If a polynomial is divided by x minus k, then the remainder is r equals f of k. We're going to get into that in a minute. Factor theorem. Polynomial has a factor, x minus k, if and only if f of k equals 0. So that, of course, means that it divides into there evenly. Now, remember when you were in 6th grade math and you talk about dividing evenly, like 2 is a factor of 6. 2 divides evenly into 6 3 times. 7 is a factor of 21. 7 divides evenly into 21. 100 is a factor of 500. It divides evenly. You have a remainder of 0. All right, so let's use these theorems. Use synthetic division to find the required function value. Now, old school, when we did these chapter 1, we would replace all the x's with 5 and type that in my calculator. Do 5 cubed minus 2 times 5 squared minus 11 times 5 plus 52. You can do these with synthetic division. I'll be honest, I can't tell you if I think there's a pro or con to it. One's not necessarily shorter than the other, just a different way to do it. This, though, they want synthetic division, so we're going to put our 5, our divisor in here. Same rules, I'm going to line up my polynomial coefficients. Make sure we're in order. If we're missing anything, 0 to hold the place. Drop your first number, 5 times 1. Add those together. Negative 2 plus 5 is 3. 5 times 3. Add. 5 times 4. Add. So your final answer is the remainder. This is that remainder theorem. So if you put 5 in for all of these x's and punch that in your calculator, you would get 72. Do I think one's quicker than the other? Hard to say. All right, let's do another one. Same thing, I'm going to use negative 4 as my divisor. Again, I'm lining up those same coefficients. We're using the same polynomial. Let's just do it. Negative 4 times 1. Add these together. Negative 4 times negative 6. Add. Negative 4 times 13. Add. So this time our remainder is 0. So if we replaced all the x's with negative 4, you would get 0. Hard to say which is better, which is easier. All right, one last one. So of course 10 is our divisor. I'm lining up those same coefficients. I'm going to drop that first number, 10 times 1. Add those, 10 times 8, 80. Negative 11 plus 80, 10 times 69. Add those up. So if you replaced all the x's with 10, you would get 742. Got it. Pros and cons. All right, last thing we're going to go over today. For the following problems, use synthetic division to show it's a solution. So if it's a solution, it divides into there evenly, and we should have a 0 remainder. Okay, I'm going to keep on reading here. Use the result to factor the polynomial completely. All right, let's do it. Value of x, they already solved it for us. They already got the solution, the 0, 2. Careful here for my polynomial, you're missing 0x squared. Drop your 1, 2 times 1. We're going to add those. 2 times 2, add. 2 times negative 3, add. All right, good news. We got 0 remainder. If we didn't, we have a problem, okay? So I'm going to recover this polynomial, 1x squared, because we're down a power from the original dividend, plus 2x minus 30. Now, it says to use the result to factor the polynomial completely. It is a third-degree polynomial, so you should have 3 total factors. Well, this trinomial we can factor pretty easily. 2 numbers that multiply to negative 3 and add to 2. 3 and negative 1. Now, where does your third factor come from? Well, that comes from your original value of x. You just have to write that in factor form, which we have done. That would correspond to the factor x minus 2. Because if you solve that for x, you get 2. So just make sure you include the original value of x in your list of factors. All right, last one. Ooh, a fraction. Good. Okay. So they already solved it for me. 4x, so 1/2, of course, is my divisor. I'm looking over my polynomial. If we're missing any terms, we're going to put 0 in to hold the place. Make sure our polynomial is always in order. And of course, we should be getting a 0 remainder since 1/2 is a solution. So 1/2 times 2, add negative 15 and 1. 1/2 times negative 14, that's not so bad. 1/2 times 20, got it. Okay, I'm going to recover this polynomial, of course. I've got 2x squared, because we're down a power from the original. 14x 20. So of course, whenever we're going to factor, always look for that greatest common factor first. I can pull a 2 out of everything. So I would start with that. And now I can factor this trinomial. I can break it apart. 2 numbers that multiply to 10, add to negative 7, negative 5, negative 2. Now, third degree, we need, of course, our third factor here. Don't forget to include the half. Now, there's no fractions in my polynomial, so I'm going to write that without a fraction. That would correspond to the factor 2x minus 1. Because if I said solve that for x, you'd add 1, divide by 2. Also, make sure you include your GCF of 2 in there. If you do not have that in your final answer, it would not multiply out to the original polynomial. Just some little hints to help you. All right, enjoy your homework, of course. Read your directions closely, whether it's a long division or synthetic. We do have a quiz coming up here on Wednesday. There's some, for the gold group, that is. Purple is the following day. Practice problems are on Google Classroom. Have a great day.